deceptively weird. For every familiar planet or glowing star, there are objects so strange, they feel like they've stepped out of a movie. Imagine a world where it rains shards of glass sideways at thousands of kilometers per hour, or a galaxy held together almost entirely by invisible matter. These aren't thought experiments or wild theories. They're real discoveries, found out there in the night sky. Each time astronomers build a new telescope or send a probe into space, the universe reveals something unexpected. Let's journey through a range of some of the strangest cosmic objects ever found, from tiny frozen relics near Earth to the largest structures in existence. Oumuamua, the interstellar visitor that shouldn't exist. In the autumn of 2017, astronomers noticed a faint dot among the stars, one of the countless objects drifting across the night. But as researchers tracked it more closely, they realized it was moving too fast, far faster than anything that could have formed within our own solar system. This discovery marked the first time humanity had ever confirmed the passage of an interstellar object, a true visitor from beyond our cosmic neighborhood. It was given a name from Hawaiian, Oumuamua, which means a messenger from afar arriving first. The name itself carried a sense of mystery and importance, as though it was not just another rock in space, but a messenger with secrets yet to be understood. From the very beginning, Oumuamua refused to fit into the categories astronomers usually rely on. Objects in our solar system, like asteroids or comets, tend to follow certain rules. They have familiar shapes, clear paths, and predictable behaviors when they approach the Sun. But this visitor broke the rules. Its speed alone showed it was not bound to the Sun's gravity. It came rushing into the solar system, swung around our star, and then began heading back into the depths of space, never to return. This made it different from anything astronomers had ever tracked before. The more scientists observed, the stranger it became. Unlike the round or irregular shapes of most known asteroids, Oumuamua appeared long and narrow, almost like a cigar, or perhaps a flat pancake, depending on how it was viewed. Its brightness fluctuated as it spun, suggesting it was tumbling end over end. That spin was itself unusual, not smooth like most rotating objects, but uneven, as if it were rolling chaotically. This alone was enough to make it stand out, but what truly caught attention was the way it moved through space. Normally, when comets pass close to the Sun, the heat causes ice within them to vaporize, creating a tail of gas and dust that pushes them slightly off course. This small boost, known as outgassing, can explain why comets sometimes accelerate unexpectedly. But Oumuamua did not show the kind of visible tail that comets produce. There was no cloud of dust, no glowing stream trailing behind it. Yet, strangely, its path showed that it was indeed being nudged by something, accelerating in a way that could not be explained by gravity alone. Some researchers suggested that perhaps it was covered in a thin layer of unusual ice that released gas without leaving a visible trace. Others argued that its surface could be made of materials we had never seen before, capable of responding to sunlight in ways unlike typical comets or asteroids. The puzzle was made even harder by the fact that Oumuamua was already on its way out of the solar system when it was discovered. Astronomers only had a short window of time, just a few weeks, to gather data before it became too faint to study. In that limited time, they could not get detailed images, only faint readings of light and motion. As often happens when the unknown enters science, the gap between evidence and certainty was filled with bold ideas. One of the most talked about suggestions came from the possibility that Oumuamua might not be natural at all. Could it have been a probe, a spacecraft sent intentionally or unintentionally from another civilization? This idea was put forward in part because the way it accelerated reminded some scientists of how a solar sail, a thin sheet pushed by the pressure of starlight, might behave. If Oumuamua were such a structure, it could explain the odd movement without requiring jets of gas or dust. This possibility ignited a debate that spread well beyond the scientific community. For many, the idea of an alien probe passing silently through our solar system was both thrilling and unsettling. If it were artificial, what would that mean about life in the universe? Had another civilization sent it long ago across unimaginable distances, only for us to catch the faintest glimpse before it disappeared again? Or was this simply a case of unusual natural behavior that we had not yet learned to explain? Most astronomers leaned toward natural explanations, though none could fully solve the puzzle. Some argued that Oumuamua might be a fragment of a larger body torn apart long ago and sent drifting between the stars. Others proposed that it could be made of solid hydrogen ice, a rare material that could evaporate without leaving visible traces, giving it the odd push observed. Still, every theory came with its own challenges, and none fit perfectly. As the debates continued, the object itself slipped further away, leaving behind only questions. By early 2018, it was too faint for even the most powerful telescopes to see. It had entered our lives suddenly, stirred up confusion and wonder, and then left just as quickly, vanishing into the blackness between the stars. In its wake, it left a lasting impression. The discovery showed us that interstellar objects are real and that our solar system is not isolated but part of a larger cosmic flow. Oumuamua's brief visit also reshaped the way astronomers prepare for the future. The possibility of other interstellar visitors became an active area of study, and new observatories are being designed to scan the skies with greater sensitivity, hoping to catch the next one earlier, with more time to study. Already, another interstellar object, Comet Borisov, was discovered in 2019, though it behaved more like the comets we know. Even so, Borisov and Oumuamua together have shown that the universe is more dynamic and connected than once believed. In the end, Oumuamua may never reveal its full story. Without direct observation or a spacecraft to chase it, the mystery remains open. Its shape, its spin, and its acceleration all point to something unusual, perhaps something unique. Whether it was a fragment of alien geology or a creation of alien engineering may remain forever out of reach. It came uninvited, a silent messenger from another star system, traveling for millions of years before brushing past our sun. For a moment, humanity turned its gaze toward it, trying to make sense of the message it carried. And then it was gone, leaving behind not answers, but a deepened sense of wonder about what else might be out there, waiting to pass through our skies. Triton, Neptune's captured backward-orbiting moon. Triton, Neptune's largest moon, doesn't quite belong where it is. Most large moons in the solar system formed alongside their planets, settling into orbits that move in the same direction as their host's rotation. Triton does the opposite. It circles Neptune backward against the planet's spin. This unusual orbit is the first clue that Triton is not a native moon of Neptune, but a captured object, pulled in long ago from a wandering path through space. The capture of Triton was likely a dramatic event. To be pulled into orbit, Triton would have had to lose a great deal of energy. Scientists think this may have happened through a collision or interaction with another large object. Some believe that Triton was once part of a binary system, two large bodies orbiting one another, that strayed too close to Neptune. In such a case, Neptune's gravity could have torn the pair apart, flinging one partner away while trapping Triton. This would explain why Triton ended up with such an unusual orbit, but capture is never a gentle process. The event would have thrown Neptune's early moons into chaos, likely destroying many of them. What we see today is the aftermath of that upheaval, a system reshaped by one moon's arrival. Triton is a giant compared to Neptune's other moons, measuring about 2,700 kilometers across, nearly as large as our own moon. Its size makes it one of the largest captured objects in the solar system. Many scientists think Triton originated in the Kuiper Belt, a distant region beyond Neptune filled with icy worlds and dwarf planets. Its composition and surface features fit this idea well. In fact, Triton bears a strong resemblance to Pluto, which likely comes from the same region. If true, this means Neptune's largest moon is essentially a captured dwarf planet held prisoner by gravity since ancient times. The backward orbit is not the only thing that makes Triton stand out. It is also one of the few moons in the solar system that is still geologically active. When Voyager 2 flew past Neptune in 1989, it captured breathtaking images of Triton's surface. Instead of being heavily cratered and ancient, like many other moons, Triton showed smooth plains, ridges, and signs of resurfacing. Most surprising of all were dark geysers erupting from its icy crust. These plumes shot nitrogen gas and dark particles high into the thin atmosphere, creating streaks that stretched across the surface. This discovery was astonishing. Before Voyager, scientists expected moons that far from the Sun to be frozen and dead. But Triton proved otherwise. Even in the cold outer reaches, a moon could be alive with activity. The geysers are thought to be powered by sunlight, weak though it is at Neptune's distance. A thin layer of frozen nitrogen covers parts of Triton's surface. When sunlight penetrates this ice, it warms the ground underneath, causing nitrogen gas to build up. Eventually, the pressure becomes too much and the gas bursts out through cracks, carrying dust and ice with it. These eruptions can reach kilometers into the sky, leaving behind dark fans on the surface. It is a delicate but powerful system, showing how even a small amount of energy can drive striking activity in the outer solar system. Triton's surface itself is a patchwork of strange landscapes. There are smooth plains that appear to have been resurfaced by icy flows, ridges that stretch for hundreds of kilometers, and areas that look like a frozen version of volcanic terrain. These cryovolcanoes may have erupted liquid water, ammonia, or other substances in the past, reshaping the moon's face. Some regions appear almost like a cantaloupe rind, with deep pits and valleys giving the surface a textured look. This variety of landscapes tells us that Triton has a complex interior, one that still holds enough heat to drive geological processes. Beneath its icy shell, there may even be an ocean of liquid water, kept from freezing solid by the pull of Neptune's gravity. Because it orbits Neptune in the opposite direction of the planet's spin, Triton's orbit is slowly decaying. With each pass, gravitational interactions drain its energy, pulling it closer to Neptune. Over millions of years, this slow inward spiral will bring it to a point where it can no longer stay intact. When that time comes, Neptune's gravity will rip Triton apart, scattering its remains into space. Those fragments may form a dazzling system of rings around Neptune, possibly larger and brighter than Saturn's. In this sense, Triton is a moon with a doomed future, destined to be destroyed by the very planet that captured it. If Triton is torn apart, it will become part of Neptune's beauty rather than its companion. For now, it remains intact, but its fate reminds us that even seemingly eternal cosmic systems are temporary. What we see today is only a chapter in a much longer story of creation and destruction. The thin atmosphere of Triton, composed mostly of nitrogen with traces of methane, is tenuous compared to Earth's, but still enough to influence the surface. The atmosphere is constantly replenished by the geysers, which pump gas into the sky. Because it is so thin, it cannot hold much heat, and temperatures on Triton drop to some of the coldest measured anywhere in the solar system, around -235 degrees Celsius. Despite this, the atmosphere is active, with winds that can carry particles from the geysers and shape patterns on the ground. This makes Triton one of the few moons with both an atmosphere and active weather, even if on a small scale. Voyager 2 remains the only spacecraft to have visited Triton up close, leaving much about it a mystery. Since 1989, no mission has returned to study it in detail, though many scientists hope that one day a probe will. Triton's backward orbit, active geology and possible ocean make it one of the most fascinating worlds for exploration. A future mission could reveal whether it has conditions that might support life, even if only microbial, beneath its icy crust. If an ocean exists, it would be one of several hidden seas scattered through the outer solar system, joining the likes of Europa and Enceladus as candidates in the search for life. The idea that Neptune's largest moon was once a free-floating dwarf planet also expands our sense of the solar system's past. If Triton was captured, then other large bodies may have been pulled into or expelled from planetary systems as well. The outer solar system may have once been a chaotic arena, with worlds passing close to one another, trading places or being cast away. Triton's existence is a reminder that orbits are not always permanent, and that even large worlds can be moved by gravity's endless push and pull. Kepler 78b, a planet that orbits in just 8.5 hours. When astronomers first spotted Kepler 78b, it seemed almost too extreme to be real. A planet so close to its star that it completes a full orbit in just 8.5 hours stretches the limits of what we thought was possible for a stable world. From Earth's perspective, we're used to thinking of Mercury as the innermost planet, baking in the sun's heat, while taking 88 days to circle once around. Kepler 78b races through that journey more than 200 times faster, practically skimming the surface of its star. It is the ultimate example of a lava world, a place where the idea of solid land might not even apply, and oceans would be made of molten rock instead of water. The discovery came through the Kepler Space Telescope, which watched thousands of stars for tiny dips in brightness. These dips happened when planets crossed in front of their stars, blocking a fraction of the light. For Kepler 78b, those dips came with a rapid regularity that stunned researchers. It wasn't just fast, it was unbelievably close. The planet orbits at a distance of only about 1.7 million kilometers from its star. By comparison, Earth is about 150 million kilometers away from the Sun. Even Mercury sits at 58 million kilometers. That means Kepler 78b is nearly hugging the surface of its star. At such a distance, the temperature on the planet's surface is believed to soar above 2,000 degrees Celsius, hot enough to vaporize many metals. Any atmosphere the planet once had would have been stripped away long ago, blasted into space by radiation and stellar winds. What's left is thought to be a bare, rocky body, glowing with heat and covered in flowing lava. Astronomers call it a superheated Earth, though that description feels almost misleading. It is not Earth-like in any sense of being habitable. Instead, it offers a picture of what happens when nature pushes planetary conditions to their breaking point. The strangest part is how it got there in the first place. Planets are not supposed to form this close to their stars. In the early days of a solar system, the heat and radiation near a star are too intense for solid material to clump together. Rocky planets are expected to form farther out, where things are cooler, and then possibly migrate inward over time. How did Kepler 78b end up practically inside its star's atmosphere? One possibility is that it formed farther out and was gradually pulled in by gravitational interactions, either with other planets or with the star's disk of gas in its youth. Another possibility is that it's the surviving core of a larger planet that lost its outer layers after being dragged too close. Either way, it challenges simple models of planetary formation. Measurements suggest that it is strikingly similar to Earth in terms of mass and composition. It seems to be made of rock and iron, not light gases like Jupiter or Neptune. Yet its orbit makes it a doomed world. The immense pull of its star is slowly dragging it even closer. Over time, astronomers estimate within a few billion years, Kepler 78b may be swallowed completely. If so, it will meet its end by plunging into the very star it orbits, erased without a trace. By studying it, scientists can better understand how close-in planets evolve, how long they last, and what becomes of them. The Kepler mission has revealed that Kepler 78b isn't alone. Many other systems also contain ultra-short-period planets, worlds that orbit their stars in less than a day. These systems are far more common than we once thought, which suggests that nature finds many ways to build planets in places that seem impossible. The conditions on Kepler 78b also let researchers test theories about how planets survive in such extremes. For example, the intense heat likely causes constant evaporation of material from the surface. Some astronomers have speculated that planets like this could create tails of gas and dust, similar to comets, as they lose mass. The interaction between the planet and its star might also create magnetic storms or unusual patterns in the star's light. These details are hard to detect, but future telescopes may be able to see them more clearly. For all its alien qualities, Kepler-78b also draws attention because it shares something familiar. Its size and density are so close to Earth's that it feels like a distorted twin. It shows that Earth-like planets do not always mean Earth-like conditions. A rocky world might be a paradise in one system and a furnace of destruction in another. This duality is part of what makes the search for exoplanets so exciting. Every new discovery widens the catalogue of what a planet can be. Before the 1990s, astronomers had no confirmed evidence of planets outside our solar system. Now, thousands are known and many are nothing like the worlds we grew up studying. Kepler-78b is one of the clearest signs that our picture of what planets should look like was far too narrow. The universe is not limited to copies of Earth, Jupiter, or Mars. It builds worlds that defy logic, that rewrite rules, and that keep forcing us to expand our definitions. Even though the planet itself is far too hot for life, the lessons it teaches might bring us closer to understanding habitable worlds elsewhere. It shows that planetary systems are dynamic, unpredictable, and often violent. The survival of a planet depends not just on where it forms, but on how it dances with its neighbors and its star. Psyche, the metal world that could be a planet core. Far out in the main asteroid belt between Mars and Jupiter, there is an object unlike almost anything else we know. It is called Psyche, named after the Greek goddess of the soul, and it is not a typical asteroid. While most asteroids are made of rock or ice, Psyche is composed largely of metal, iron, nickel, and other heavy elements that shine faintly in the sunlight. This makes it unique, because in many ways it looks less like a leftover rock from the solar system's formation and more like the heart of a world that never fully came to be. Astronomers believe Psyche might be the exposed core of an ancient planet. Billions of years ago, when the solar system was young, countless planetesimals, small developing worlds, were colliding, merging, and breaking apart. Some grew into the planets we see today, while others were destroyed in violent crashes. Psyche may be one of those lost bodies. At some point, it might have been a much larger world with a rocky mantle and a thin crust, but a massive collision could have stripped away those outer layers, leaving behind the metal interior. What remains now is a naked planetary core, orbiting the Sun in silent isolation. On Earth, the core lies thousands of kilometers below the surface, hidden from direct observation by layers of rock and mantle. We can only study it indirectly through seismic waves and magnetic fields. But Psyche gives us a chance to look at such a core directly. If it truly is what scientists suspect, then it could hold the answers to questions about how planets form, how their interiors evolve, and why some worlds grow to be habitable, while others remain barren. Psyche is massive compared to most asteroids. It measures about 220 kilometers across, roughly the size of the state of Massachusetts. Its surface appears to be a mixture of metal and silicate rock, with shiny regions that reflect more light than expected. Radar studies have revealed its density is lower than pure iron, meaning it may not be solid metal, but rather a porous mixture of metals and rock. Still, its composition makes it unique in the asteroid belt, a place dominated by rocky fragments and icy bodies. The idea of standing on Psyche is hard to imagine. Unlike rocky asteroids covered in dust and boulders, its landscape might be made of gleaming metal cliffs and jagged slopes, stretching across a world that has no atmosphere, no wind, and no water. Some parts of its surface may contain shiny metal plains, while others could be covered in darker rocky patches. Scientists have even speculated about what impact craters might look like on a metallic world. Instead of shattering like rock, metal might bend or deform, leaving strange shapes unseen on other planetary surfaces. This unusual nature has made Psyche the target of one of NASA's most ambitious asteroid missions. The Psyche spacecraft, launched in October 2023, is currently on its journey to reach the asteroid in the late 2020s. Its mission is to orbit and study Psyche up close, using a suite of instruments to map its surface, measure its gravity, and analyze its composition. For the first time in history, we will be able to directly explore what could be the interior of a planet-like body. One of the mission's main goals is to understand whether Psyche really is the core of a failed planet. If it is, then it represents a piece of the solar system's earliest history, frozen in time for billions of years. It would show us what the insides of rocky planets look like, offering a rare chance to test theories about planetary differentiation. The process by which heavier materials sink inward to form a core, while lighter materials float to the surface to create a crust. On Earth, this process gave rise to the iron-rich center that powers our magnetic field, a shield vital for protecting life. Psyche may show us what that process looks like in its rawest form. Another question is whether Psyche might contain evidence of unusual materials. Some researchers think the asteroid's surface could hold large amounts of valuable metals, including iron, nickel, and even platinum or gold. While this has sparked headlines about its potential trillions of dollars worth of resources, the mission is not about mining, it is about knowledge. Still, the fact that Psyche may contain so much concentrated metal raises fascinating questions about how common or rare such bodies might be, and what role they play in the story of planetary formation. The spacecraft heading towards Psyche carries a number of instruments designed to unravel its mysteries. A magnetometer will search for any remnant magnetic field, which would suggest Psyche once had a molten, active core like Earth's. Gamma-ray and neutron spectrometers will study the surface chemistry, telling us exactly what elements are present. Cameras will map the terrain in detail, revealing craters, ridges, and strange features we can only guess at today. Together, these tools will allow scientists to build a complete picture of this unusual metal world. If it were purely a core, we might expect it to be solid and extremely dense. But its measured density suggests it may be a mixture of metals and rock, or even metal with significant empty space, almost like a sponge. One theory is that it is not a pure planetary core, but a kind of hybrid body, partly melted and reformed in the chaos of the early solar system. Another idea is that it was shattered and reassembled multiple times, creating a patchwork structure unlike any other world. If it is a core, why is it exposed? If it is a mixture, what process created it? If it was shattered, how did it hold together over billions of years? By visiting it directly, we may begin to answer these questions, but we may also find answers that challenge what we thought we knew about how planets form and evolve. Psyche is a reminder of how much of the solar system remains unexplored. We often imagine that the main discoveries lie far away, around distant stars, or in the outer reaches of the cosmos. But Psyche shows that even within the familiar bounds of the asteroid belt, there are worlds that defy expectation, worlds that hold secrets about the very beginnings of planets themselves. For scientists, it is a rare chance to study a place that could serve as a window into the hidden hearts of Earth, Mars, Venus, and Mercury. As the spacecraft draws closer in the coming years, each transmission will bring us closer to seeing Psyche as it truly is. The images and data it sends back will not only tell us about this single body, but also help us piece together the story of how worlds like our own came to exist. Psyche's metal face may look barren and silent, but beneath it lies a record of cosmic violence. In its scars and its shine, it carries the memory of a time when planets were still being born, a time when the solar system was raw and unsettled. Thorne-Zitkow objects, stars within stars. Most of the time, the life cycles of stars follow patterns that astronomers understand fairly well. Small stars like the Sun end up as white dwarfs. Larger stars explode in supernovas and may leave behind neutron stars or black holes. But sometimes, the process can take a strange and unexpected turn, creating objects that almost seem like they should not exist. One of the strangest ideas ever proposed is that of a Thorne-Zitkow object, a star hiding inside another star. The idea was first suggested in the 1970s by physicists Kip Thorne and Anna Zitkau. They imagined what might happen if a neutron star, one of the densest objects in the universe, somehow